Okay, before, yeah, let's just remember our circuit with a one transistor. Remember our circuit, so we have here we have the light bulb or LED, whatever, and here we have the transistor. Can be MOSFET, can be anything, you know, that's not important what it is in this moment. But what do we have here? If you remember, we have that resistor, right?
Yeah.
To ground, and we were adjusting the light, the output light, from this adjustable resistor. You remember?
Yeah.
You remember? So on that case, how transistor it will act to the current flow, the major current flow, it will be like that, right? How transistor it will change the light intensity. Okay, I build here a circuit for you.
Okay.
Yeah? Here is minus, here is plus.
You still see the current flowing? No.
No, but you'll see it soon. So if I build it, you have to draw the schematic. You understand? So I want to see you drawing this schematic. It's part of the,
You hate me or something? Bullying?
No, you can do it. You can
Bullying the student?
You can do it. Okay, so draw the schematic.
Okay. So
first you draw the power line, plus and minus.
So here we have plus.
Yeah.
Here we have minus.
Yeah.
Okay.
And you draw two lines, long lines.
Like this?
Yeah. Good. Now, draw the schematic.
Easy.
Yeah, you see.
Easy. I can draw two lines.
Yeah.
Plus and minus.
Now next.
Next. There is a lot of things here.
You have like 2 components or 3 components, and you tell me there are a lot of things?
I have 4. Yeah.
Where are 4?
Look, the resistance there.
Oh, okay, it's one more resistor, yeah. Okay, 4 components.
Yeah.
All you have to do is to put 4 components on the screen.
You saw the current, I saw the resistance, you see? You know, you think I'm not crazy. I cannot see the current because it was not current.
Not yet.
Yeah, but you said, look, I can see the current.
Yeah, but not currently.
Where you can see the current because it's not connecting to anywhere. Like, you cannot see it.
In my mind.
Oh, okay. So after you learn all of this, you get a bit crazy and then you understand what's happening here. Okay.
Okay, draw the schematic.
All right. So we have the bulb. From where?
No, we don't have a bulb.
We have a LED, sorry.
Yeah.
We have the LED. Where should I put the LED? Here?
Be up to you.
Like here? Like this?
That's not a LED, that's a light bulb. That one with the X is a light bulb.
Okay.
I want you to draw a LED. So basically what you try to tell me is your LED is connected to plus, right? I can't say connected to plus, but if you say, yeah, why not?
No, it's connected to minus. Wait.
Okay, one more time.
Okay, one more time.
Look here, I can put the LED here. Look here. I can put the LED. You see? That's the LED, and then I'm coming to the transistor, and this one is going to a resistor here, and it's connected to plus, right? Yeah. You can see?
No. Wait a second. So the LED is here. But yeah, the LED is here, right? How you can do the LED? like this. Like this? That's the LED?
No, the LED is like a diode, like the diode sign.
You know, I'm not good at drawing.
So basically what you try to do to connect the LED, to draw the LED near to the minus line, but your LED is near to the plus, right? I'm just trying to understand your actions.
You know what? The LED is right here. Look. Wow, that's the freaking LED.
That's not a diode sign. I will show you the diode sign.
Okay, wait. How the... like this? It was like that?
No. Let me show you the diode sign, yeah?
Okay.
So this, it's a diode. Check here.
Oh, okay.
And here is plus, and here is minus. That's a diode.
Don't laugh.
That's right. That's a LED.
So this is a LED. You see, it's a LED.
I want the symbol of the LED.
I was going to say something bad. Forget about the symbol.
No,
right?
No, you can't forget about the symbol.
Yes,
Symbol is sacred.
This comes so this is a LED. Here you have a resistor. Boom. Then wait. Here you have the 3 legs transistor. 3 legs transistor. Okay, has 1, 3 leg transistor. Okay, and
okay, so this is a transistor. Inside the transistor, you have 3 junctions. On our case, you have an N junction, you have a P junction, and you have an N junction. Each junction has a pin, yeah, which actually is connected. So this is called base, this is called a collector, and this is emitter if it has the arrow, right? So it has to have the arrow pointed out, as this is an NPN transistor. Now, like how I told you, and I told you, probably you didn't remember. If you apply, current to the base, but I said, you know what, current maybe is too complicated word. So let's say 0.7 volts on a transistor. That's what I said. Now, when you apply voltage to this junction, actually inside of the transistor, the other 2 junctions, it will start driving the power. You understand?
okay.
So in this case, you will have 2 current flow, So you will have, as soon as you apply voltage to the base, you'll have a current flow from this junction to this junction, which is getting close to the ground, And you will have your major current flow from the collector to the emitter and out.
Okay.
Yeah, but okay, you said last time and you didn't remember. On the same way, I told you, I want to have in mind the transistor as being as adjustable resistor, right?
Mm-hmm.
That of course depends how you are using the schematic. So this is the adjustable point where you can adjust the resistance up and down, right?
Mm-hmm.
And this is handled by the base pin, yeah? That's what I said.
Mm-hmm.
So, what you don't understand? If you don't tell me what you don't understand,
But I forgot, okay?
what do you mean you forgot?
Simple. You said it once.
Okay.
And then you said other things, and other things, and other things, and other things. And obviously, what you said before, it's gone. You have to say it again.
Let's show you in a different way, yeah? So you have the transistor.
Mm-hmm.
So this is the emitter, yeah? Okay?
Mm-hmm.
This is the collector. Now here you have your light bulb, yeah? You have a light bulb. And here you have a battery, right?
Yeah.
Plus and minus. You understand?
Mm-hmm.
Okay, without having any current applied to the base, you'll not have a current flow. You understand?
Mm-hmm.
Nothing it will happen. The light bulb, it will be off. Is that clear?
Yeah.
Okay. Now let's connect a second battery into the base and emitter, yeah, with the plus here and the minus here. And this it will be 0.7 volts. So if you connect the battery here between the base and emitter,
Mm-hmm.
the transistor, it will start driving power. You understand?
Mm-hmm.
And this is the circuit. So you have two currents flowing on this circuit. This one and the second one is this one. You understand?
Mm-hmm.
You have two different currents flowing through this circuit. Yeah?
Yeah.
Good. Now, remember our schematic?
Mm.
Remember what I told you that actually the transistor is amplifying the signals?
Yeah.
So what we did, amplifying the signals means if here I have a low signal, I mean with like 0.7 volts, I can switch this to drive the power, to drive like high current, like light bulb. This light bulb was taking like what, like 400 milliamps?
Okay.
Yeah. So here, all what I need microamps. You understand? So that's the amplification.
Okay.
With microamps here, I can make this transistor driving like 400 milliamps.
Okay.
Yeah? And I said, you know what, let's connect the base through the resistor to the plus. Yeah? What the resistor it will do? What a resistor is doing?
It's resisting the current.
Is limiting.
Limited, sorry. Limited.
Limiting
Limiting
the current.
the current.
Right?
Yeah.
Because the transistor, this is opened by current.
Yeah.
MOSFET is opened by voltage, right?
Yeah.
Okay. And we're gonna have, yeah, on this case, the transistor it will limit the current. If it will limit the current, I will have here probably 0.7 on the base.
Mm-hmm.
Depends on the transistor, of course. And I will have two current flows. I will have I will have one current flow, yeah, like this, right?
Mm-hmm.
On this direction, yeah?
Mm-hmm.
And I will have a second current flow, through the resistor, base, to the emitter and to the minus. Sorry, yeah. On the same direction.
Mm-hmm.
You understand?
Yeah.
Okay. And then what I said, let's come with adjustable resistor, which adjustable resistor is nothing like actually a metal, yeah,
Mm-hmm.
sliding on a carbon layer. It's exactly like that. Yeah? So this is carbon.
Mm-hmm.
You understand?
Yeah.
And this is sliding actually through the carbon. And this one connected to the plus.
Okay.
Now in this case, what I will have two current flow. I will have multiple current flow. So one here, yeah,
One to the resistor, to the adjustable resistor.
where?
Go down.
Yeah,
And then to the base and the emitter. Like that.
okay. And what is the voltage across this resistor? So what will be the voltage if you check it with the multimeter from here to here?
It will be 0.7.
How?
Oh.
You have this track, yeah? This track is coming straight from your battery.
Okay.
You can see it?
Yeah. Oh.
So what voltage will be there?
What voltage you have on the battery?
Exactly. So I'll have the battery voltage.
Yeah.
That means if I have a resistor here, I will have a current flow. You understand? From the plus to minus.
Oh, okay. So you have a third one.
Exactly. You have a resistor between plus and minus.
Yeah.
Of course it will be a current flow. How do you think you can adjust here on this one to have 0.7 volts?
With the resistor.
Okay, let's go back and speak about adjustable resistors. So you have a resistor, yeah, which is connected, I said, minus and plus. Let's say 12 volts. Yeah? This is carbon. And you have a metal, which is touching this from up to down, and obviously it's changing the resistance.
Mm-hmm.
I mean, this resistor has like 10 kilo ohms, right? Let's say 10 kilo ohms. Yeah?
Mm-hmm.
Obviously, if my arrow is here, yeah, I will have what? I'll have probably from here to here, I will have 9 kilo ohms.
Mm-hmm.
And from here to here, I will have like what? 1 kilo ohm,
yeah.
right?
Yeah.
On the same way with the voltage. So it will be the same. So from here to here, if here are 12, probably here I will have 10 volts.
Yeah,
Yeah.
and there you have 2.
And from here to here, probably I will have 2 volts, right?
Yeah.
So I can go even lower to have exactly what I need, like the transistor 0.7 volts.
Yeah.
But what will happen in this case? Yeah, you have 2 volts here.
Yeah.
So you come with a resistor, you come with a transistor, right?
Mm-hmm.
Which will have another current flow, as soon as you connect the transistor. and you will have this current flow. Check here. Yeah, this, and this. Yeah, and you'll have this. Now, as soon as you connect the transistor, like how I told you in the beginning, everything is a resistance. From here to here, you will have a resistance, because without a resistance, your current, it will not flow from the base to the emitter.
Mm-hmm.
Then you will start having a divider, so having here a resistance and a parallel mode with this resistance. You understand?
Yeah.
Because from here to here, we said we have like what? Like 1 kilo ohm, right? That's what we said.
Yeah.
You have 1 kilo ohm, you have another resistance here, which I don't know what resistance is here. So the voltage, it will be even lower here. As soon as I connect the transistor.
Yeah.
But you understand, that's the thing. What will happen if you have resistance in a parallel mode? What will happen with the total value? We spoke about how you connect the resistor in a serial mode and a parallel mode.
Yeah. It will be lower.
It will be lower, so I will not have 1 kilo ohm, I will have less. That means I will have less voltage
less
here.
voltage. Yeah.
You understand? That's how this is working. Actually, this schematic is not right, because if you move this arrow, you move this arrow, or you move it here when you adjust, yeah?
Mm-hmm.
You'll have too much current on the transistor base, or too much voltage. And you can burn the transistor. So you understand? Now, on this case, when actually you adjust the base, yeah, you can adjust the light intensity on the light bulb, right?
Yeah.
So that means the transistor, it will act as a variable resistor. How do you think you change the light intensity on this bulb?
With the transistor.
Because the transistor...
Yeah, became a variable resistor.
Exactly. So what will happen, let's say, if I don't have that much light? If I don't have that much light, or depends of the current, yeah? Let's say 400 milliamps is like full brightness, so I'll have 200 milliamps. That means that my transistor, we can check by the ohm law, probably my transistor has 5 ohms. You understand? Be checked from here to here. You understand?
Yeah.
So 200 milliamps, it's about 5 ohms. I can't write. Okay, 5 ohms. Now, in order to lower the brightness of the light bulb, yeah, that means that your transistor has to lose some current. Yeah?
Yeah.
You understand?
Mm-hmm.
So having a resistor here, what will happen with the resistor when it's losing current?
What will happen with what?
With a resistor, yeah?
Mm-hmm.
Because this is like a power resistor, the transistor.
Yeah.
It can handle a lot of current.
Yes.
Like 200 milliamps.
Yeah.
So what will happen with this resistor? A resistor is losing current. It will get hot. You see what's the problem here? The problem here, because you are scared to be wrong, you don't tell me.
Yeah.
If you don't tell me, I have no idea. We are just moving forward with every video, but you actually didn't understand.
But I do understand.
Okay, you know what? Let's do something. It is any point broke this to show you how you change the resistance when you adjust this?
No.
So you understand?
Mm-hmm.
Okay. So what you don't understand here?
I understand.
I don't think you understand. Let me take the light bulb. Because when you are getting burned, you remember that burn. Yeah. So you will remember if you get burned. Of course, that's not the idea to get burned. The idea is to feel what is happening. To understand, it's nothing free. So you light up the light bulb, it will get hot. A transistor, it will get hot. So I want you to understand this. Okay? So let's check this schematic together. So what is the current?
It's 0.01.
How much is that?
It's 1 milliamp.
No.
0.01 amp.
Yeah.
Yeah.
It's 10 milliamps.
Oh, 10 milliamps.
So you see the light bulb, it's off.
Yeah.
You can see it?
Yeah.
Good. Now adjust the resistor. Yeah, that's all. So what's the current now?
It's 0.44 amps.
Okay, so how many milliamps?
460 milliamps.
Okay. So check the transistor.
It's a bit warm, a bit.
Okay, let's raise the current.
Rise?
Rise. That's all. So what is the current on the power supply?
It's 740 milliamps.
Check the transistor.
It's getting warm. Yeah.
So it's safe to say this is acting as a adjustable resistor?
Yeah,
See, it's hot?
it is. Yes.
Yeah?
Mm-hmm.
Okay. Raise the current even more. Why that happen?
Cause it was too much current
Where?
on the base.
Exactly.
it was going up then 0.7.
Yeah. Actually, the current was going up. Obviously, the voltage was going up. Yeah. And the adjustable resistor got burned, right?
Yes.
Yeah. Yeah, that's the smell of a burned resistor. Let's see if it's still working. It's not working. You kill it. I can't believe you killed the resistor.
So that was the lesson for today. The patient the surgery get good. The patient is dead.
Okay, let's do something else. Yeah?
Yeah. We're gonna burn something else.
No, I'm gonna connect the base straight to the. 1 second. Yeah.
Mm-hmm.
To the plus using a resistor. Something make me believe actually only when something bad happen you will learn.
Wait, it's gonna happen again?
No,
Something bad?
I'm just saying.
Right.
Okay, let's see now. Yeah. So what is the current?
It's 830 milliamps.
So it's even higher.
Yes.
Yeah.
Mm-hmm.
Okay. You hold that for me, please.
Watch and learn.
Yeah.
Mm-hmm.
So the current goes up,
Yeah.
right?
Mm-hmm.
Check the transistor.
It's cold.
Why?
Oh my God, you
No,
scared me.
why? This is very important. Why the transistor is cold? We raise the current, but the transistor is cold. Why that happen? That's very, very important.
And because of this resistance.
What do you mean? We raise the current, yeah?
Yeah.
So this current. So one more time, the current circuit, yeah, we have one current flowing like that, right?
Mm-hmm.
And what's the value of this current?
That's 12 volts.
Yeah, that's the potential, the voltage.
Yeah.
Okay, what is the current? The current is in amps.
Oh.
But you checked on the power supply. What was the current?
Yeah, it was like 800
milliamps.
800 milliamps.
Yeah, that's all. That's all what I want to know. Yeah?
Yeah.
So this is one current flow, and the second current flow is like this, right?
Yeah.
Okay. Why the transistor is cold?
Because this resistance was limited the current.
Okay, so if the transistor is limiting the current, actually my transistor is cold? Why the transistor is cold? With 800 milliamps, transistor is cold. With 400 milliamps, the transistor is hot. Right? You
Yeah.
checked?
Yeah.
Yeah. Why that?
Because you put a bigger resistance on this side.
Bigger resistance. What do
Yeah.
you mean? I don't think you understand what kind. So what kind of current do you think is flowing from this resistor? So what current do you think is flowing to the base? You know, just say roughly how much current do you think is flowing here?
I don't know, less than 400?
Okay, let's check together. You see? You still don't understand amplification. Okay, let's check together. So you have the multimeter. How we are checking the current? How we are checking the current? How we are checking the current?
How we are checking the current?
Yeah.
From the...
Like you want to check a current. How do you check the current? We spoke about that. How we are testing the current on a circuit. We said when we are checking a current, right? I said we are inserting the ammeter in the serial mode with what circuit we want to check. So we're gonna have a current flow through the resistor, ammeter based. So that's how we will know what current is there. So the ammeter, it will be in the serial mode.
Okay.
You understand?
Yeah.
Okay. Let's do it. Insert the ammeter on the serial mode. Yeah, that's the worry.
This one?
Yeah. On the serial mode with the base.
So that's the wait. That's the base.
Yeah.
That's the base.
Yes.
And on this one, right?
In the serial mode. And the serial mode.
Like this?
No.
No.
That means you have to break the circuit.
Oh.
To put the multimeter on the middle. Yeah. And on that point, you will see what current is flowing on that circuit.
So.
That's what I said.
Here, this one.
Yeah.
And this one here.
Yeah. And I will use the power from here to the plus. Where is the plus? Yeah, here. This current is too high. 1 second. So what is the current? He's saying on the
It's minus 22.
no, minus because okay, spin them around. Spin them around. Because I said on the serial mode. On the serial mode, you minus here and plus here because here is plus, right? So what is the base current?
22.72 milliamps.
Okay, so you see, it's like 20 milliamps. So the current flowing here, I is the current.
Yeah.
I equal 22 milliamps. Yeah?
Mm-hmm.
So with low current onto the base or low voltage, I can handle high current from the collector to the emitter. Right? We said that?
Yeah.
Okay. Why the transistor is not getting hot? Okay, let's do it in a different way. Because it's essential to understand why with higher current your transistor actually is not getting hot, because it doesn't make sense. The transistor is carrying more current, right?
Yeah.
So it should get hotter. Okay, so we know here is flowing 22 milliamps, right?
Mm-hmm.
Okay, check the voltage between the base and emitter. 1 second.
Base and emitter.
Yeah, what is the voltage?
0.7.
So you see?
Yeah.
So 22 milliamps equals
0.7 volts.
okay. Okay, you still don't understand. What is the R? Okay, so what do I want to check now, yeah? So what is the voltage on the power supply? 12 volts, right?
Yeah.
It is 12?
Yeah.
Good. Now I'll hold press here. I want you to check the voltage on the light bulb. So what the voltage do you think it will be on the light bulb? So what's the voltage do you think it will be on the light bulb from here to here? Let's check. Let's see. Let's see what voltage do you have, yeah? So you have to check across the light bulb. Across the light bulb.
Across the where?
Yeah.
From right here?
You can take it. You can check here. If it doesn't,
Okay.
it will make you happy. It's fine. Yeah. What is the voltage?
It's 11. I cannot hold it.
Why?
Because it's hot.
It's hot.
Yes. I cannot hold it. 11.6.
So basically, you have nearly the input voltage.
Yes.
That's
12.
mean it's the same case, yeah? It's the same case like connecting the light bulb straight to the power supply.
Yeah.
Right?
Mm-hmm.
So just roughly, yeah, if you have 12 volts, right? You said 12, yeah?
Yeah.
12, nearly 12.
No, nearly 12.
Okay.
It was 11.6. Yeah.
What will be the resistance of this transistor?
Wait, we know the current. No? We know
The current is not important.
Okay.
I mean, I have 12 volts here. Yeah? That means my transistor is like a wire, right?
Yeah.
Because how you can have, the transistor is regulating, the minus which is coming here. Or if you think of the current flow, okay, you have the light bulb, but then the transistor is regulating the current, then it's going to the minus. So what it will be the resistance of the transistor?
It will be the voltage divided by,
You want to calculate?
Yeah.
Okay, don't calculate.
Okay. But I'm still thinking to calculate.
No, don't do it. Don't do it. Don't do it. Just tell me the resistance. Because it's very simple. I have input 12 volts. I have 12 volts on the light bulb. What will be? It will be the resistance there.
It will be like, I don't know, half of the.
Just tell me in ohms. In ohms. How many ohms?
I'm still thinking to calculate.
Okay, let's do it on a different way then.
No calculation?
No.
No formula?
Because you want to calculate because you don't understand. That's why you want to calculate.
Obviously.
Okay. So just imagine. Yeah? You can imagine?
Yeah.
Good. This is our transistor. This is the transistor. You have collector and emitter, right?
Yeah.
Okay.
But that's the wire.
I know.
It's a wire. It's
I know.
not a transistor.
I know, but you can check what is the voltage on the light bulb, right?
It will be the same, right?
Okay, then check the resistance of the wire. Yeah. What is the resistance of the wire?
It's 0.2. No, it's 2.33, sorry.
I don't think you are touching.
Um,
What is the resistance of these wires? 2 ohms?
yeah.
Yeah, that's my cheap multimeter. Yeah. Check now.
One ohm. 0.99. 0.9654.
So what is the resistance of the wire?
It's 0.80 now. 90.
But, okay, check only the multimeter together.
Oh, it's 0. But
So it's 0.7?
yeah,
Okay, check the wire.
0.7, and this is.
You are not touching.
I'm
You
touching.
are not touching. It's impossible to have like 10 centimeters wire to have like 0 point something ohms.
I'm even holding it. Look, I'm holding. I'm touching. I'm touching.
It's impossible to be 0.
I mean, those things are so cheap. You know, look at those values, like changing like every single second. You're not touching. You are not touching.
Check there.
Check
It's
there.
0.8, right?
Yeah, but earlier was 0.9.
If I touch those two, it's about the same.
Yes.
Yeah?
All right.
So what is the resistance of the wire?
It's 0.1. 10, sorry. 10. It's 0.10.
Okay. Okay, let's do it in a different way. Check the resistance now. So what is what?
You know what? Let's do it in a different way. Buy a good multimeter, and then we're gonna do it.
Okay, do it now. Yeah.
Okay.
Check now the resistance of the wire.
Of the.
Okay, what is the resistance now?
So early was 0.70.
Okay, check now. Now we are on a different scale. Now we are on a kilo ohm scale. You
Okay.
can see that, yeah? So what is the resistance?
0.02. 1.
Okay, check the wire.
0.0.
0.00, yeah? Right?
0.03210.
Wait.
Okay.
Yeah? Okay, check the wire.
Five, 4, 3, 2, 1. And it's not moving.
This is crazy. No, you are not keeping. You are not touching. Look.
I'm touching
You
it.
are not touching. 0. Look there. 0.
I mean, if you want to say 0, then put it on 0 and that's it.
Okay,
you know?
it's
But
0.
I'm touching it.
Okay, but you understand it's 0.
I'm gonna eat those wires. I'm touching it. Look,
If you are touching,
touching it properly.
Should be 0.
4, 3, 2.
Now you see?
Now it's 0.
You see, you are touching. So you see, it's no difference if you short those or your wire. So what is the resistance of the wire?
0.
0.
Yes. Yeah.
Okay. So with 0 ohms resistor, we have on the light bulb
12 volts.
same voltage, compared
yes.
with the power supply.
Yeah.
So what is the resistance of the transistor between the collector and emitter? If you have on the light bulb same voltage.
It will be 0. No, yeah.
No, you want to say something else.
Yes.
Just say it.
Yes.
No, just say it.
Yes.
You said no.
Because you said every single thing has a resistor inside. That means it cannot be 0. Right?
It cannot be 0. What do you mean? A wire has a 0 ohms.
Yes.
So?
Yeah, but that's not a wire. That's a freaking 3 legs transistor.
And I told you what a transistor is doing. I told you what it's doing. It's a variable resistance, yeah?
Yes.
Variable means 0 up to infinite.
Okay. And you want me to guess what resistors we'll have now? It's a variable. Can be 0, can be...
I know. But if you have same voltage on the light bulb, compared with the power supply, what is the resistance of the transistor?
It will be variable.
Yeah, it is. But you have 12 volts.
Okay.
And the transistor in the serial mode with the light bulb, yeah?
Mm-hmm.
So we already agree the transistor is a variable resistor, right?
Yes.
Okay, so what it will be the resistance of the transistor?
Yes, but accordingly, you said every single resistor, diode,
okay, yeah.
every single thing has a resistance inside.
You're right.
Yeah?
Yeah, but 0 ohms, it is a resistance. You understand?
You did not say that.
That's 0 ohms.
Yes.
That's 0 ohms. Look, that's 0 ohms. That's a resistor. You don't think actually this wire is a resistor?
No.
Okay. Okay.
Has 0. How can be a resistor?
Very simple. I will show you how. So you said a wire which has 0 ohms cannot be a resistor. That's what you said. Right?
But you said early, it's not...
It's not what?
It's a wire.
Yeah. I told you the resistance of the wire. Look, it's like 0, right?
Mm-hmm.
Okay, good. Now let's get a power supply and let's make a circuit. Yeah. So if this is a resistor, what will happen with the resistance when we are coming with power? It will start losing current, right? Current is exchanging on what? And heat, right?
Yes.
Okay.
And now what? You have to prove me that the wire is not getting hot?
The wire is not getting hot?
This
Yeah. Huh? I told you that's the only way you will learn. Touch it again. Why you don't touch it? Why you don't touch it? No. You said it's not a resistor. That's what you said. It's not a resistor.
It's smoking.
Look, it's smoking.
It
But
is.
you said it's not a resistor. Look here, it's smoking.
It's smoking because it's melting. What do you mean?
Yeah, why is melting? That I'm trying to explain you. You can actually calculate. Look, you said it's not a resistor. That's what you said.
Yeah, touch it.
No, you touch it. So why this wire was getting hot and start burning? Why?
Because he has the resistance.
Exactly. Yeah? So there is no perfect 0 ohm wire or resistor or whatever.
Okay.
Okay?
Mm-hmm.
Good.
Good.
Now, what resistance it was on your transistor?
It was 0.
How do you know?
Because, I don't know.
What was the resistance on your transistor? It's a very simple question.
So wait, that was a 12 volts, right?
Yeah, so we have 12 volts and on the light bulb we have 12 volts. What is the transistor resistance?
0.
0. Okay. Why having 0 ohms here, yeah?
Mm-hmm.
This is burning, is getting hot, but not my transistor which has same resistance. Yes, 0 ohms.
That's a good question.
Why?
Wait, I think we spoke about this.
Yeah, we spoke. We waste 2 hours explaining, the power of the resistors. But yeah, you forgot.
I did.
Okay, so why the transistor is not getting hot, but my wire is getting hot?
Wait, I don't think we spoke about that.
Please kill me.
No.
You can shot me.
Wait a second. We spoke about the transistor is getting hot because of blah blah blah. But I don't think we.
Okay, so we already I agree.
Yeah.
0 ohms. It's theoretically something can have 0 ohms, but nothing has 0 ohms. You remember?
Yeah.
We just spoke like a few seconds ago.
Yeah.
So we agree the wire doesn't have 0 ohms, are close to 0 ohms, but not 0. Yeah, close to 0.
Yeah.
The transistor cannot be 0, can be close to 0, right?
Yes.
But why the wire is smoking and is getting hot and my transistor not? Okay, let's try again. No, it's...
We can try like 100 times.
No, he's not. He's not like that. Let's try again. So what will happen with this wire? What will happen with this wire?
That's the moment when you are a student and you don't have colleagues to ask them, hey.
Okay, so what will happen with my wire? What will happen with my wire?
It's smoking.
Okay, let's see. It's smoking?
It is, yes, look. Oh, you see? It's smoking already.
Okay, let's see if it's smoking.
It is.
It's not.
What do you mean it's not? Look at the smoke.
Okay, I failed to prove the point. One second. Give me 1 second. No, it's fine. Give me 1 second. Okay, I failed to prove the point, but I will do it now.
Okay.
Okay, so let's connect this wire.
Oh, you bring a bigger one.
Okay.
Okay.
We connect a wire which has 0 ohms, right?
Mm-hmm.
We already agree there is no 0 ohms.
Mm-hmm.
So what will happen with this wire? Look, it's taking 5 amps, you can see?
Mm-hmm.
So, it is getting hot, it is...
No.
Why? That's the question, why?
Wait, because this one has a lot of wires there. They have a lot of wires.
Yeah, and what does mean?
It means more wires can carry... Every single wire can carry current and it's not getting hot.
Okay, so it's about the resistance and it's about the power. You understand?
Yeah.
I will not ask you again. It's about the power of the resistor. You understand? So even if two wires, they are the same, it's about the power.
Okay.
You understand? So yeah, indeed, you can see this wire can carry more current.
Yeah.
You understand?
Yeah.
Okay. So you understand why the transistor is not getting hot?
Because he can carry more current than we have. It can carry more than 12 volts. No,
That's voltage.
No, that's voltage. More than, we have 800 milliamps.
Yeah.
This one can carry more than 800 milliamps.
Yeah, but that's not the reason why it's getting, why it's cold.
Okay.
So what's the reason why the transistor, it was hot, carrying 400 milliamps, and it was cold, carrying 800 milliamps? Okay, what will happen with the transistor? We are speaking exactly between collector and emitter. That's what we are speaking.
Okay.
What will happen between the collector and emitter if the current is half? If it's not 800, it's 400.
Yeah, but we have the same, like 400, and it was getting hot.
Yeah, I know. But what 400? How the transistor is limiting the current to 400 milliamps?
I need to watch the video again.
No, it's simple. What do you mean? Okay, you want me to limit the current to 400 milliamps on the light bulb?
No.
Okay, let's do it.
No, wait.
And we have the power supply. Just hold the wires here and here.
Where you want me to hold the wire?
Here and there. No, you need a power supply.
Oh.
Yeah.
Here
Yeah.
and here.
Yeah. Okay, so what's the current?
360 milliamps.
Okay. Okay, so what's the current?
430.
So can we say this resistance was the resistance on that between the collector and emitter on that point when we had 400 milliamps for the transistor?
Yeah.
Okay. What happened with the resistor when it's carrying 400 milliamps? Huh? What do you think will happen? Or what do you think is the resistance of the resistor if there we have 400 milliamps? Let's check together. Test the resistance of this resistor. Yeah, so with this resistor we have 400 milliamps, right?
Mm-hmm.
Okay, check the resistance. Yeah, and here. So what is the resistance?
18 ohms.
18 ohms. So what the resistance was with this on this transistor between the collector and emitter when we had 400 milliamps flowing from the light bulb?
It was like 22. Was 22?
No,
No.
you're speaking about the base current?
Oh. I can't remember. Wait, it was 40 something, 47.
Okay, so we tested before, right?
Mm-hmm.
Just forget about the base, because I think you are getting confused. So we checked together, and we had 12 volts,
Mm-hmm.
yeah, 400 milliamps, yeah?
Yeah,
The current flow was 400 milliamps, right?
yeah.
Good. And now we test with a resistor, yeah? We tested?
Mm-hmm.
Okay, 12 volts. So basically I connect the resistor, yeah?
Mm-hmm.
Then the light bulb, yeah?
Mm-hmm.
And to the minus, right?
Yeah.
It doesn't matter, minus, plus, 12 volts. Yeah? And the current flowing was 400 milliamps, yeah?
Yeah.
But 400 milliamps, yeah, what was the value of the resistor? You tested. What was the value?
It was 18.
18 ohms, right?
Yeah.
18 ohms, yeah? So a current flow of 400 milliamps, yeah, means on a serial mode with the light bulb, I should have 18 ohms resistor.
Yeah.
So what is the resistors, internal resistance, from the collector to the emitter if I have 400 milliamps current flow?
It will be 18.
Exactly. Why the transistor is getting hot with 400 milliamps but not with 800?
Because this one was in the serial, that on the 400.
Okay, and the 800 was same on the serial. I mean, I don't understand. So we agree with 800 milliamps, 400 milliamps equals 18 ohms, right?
Yeah.
18 ohms. Okay, 800 milliamps, yeah? We agree it's somewhere around 0 ohms, yeah? So why was getting hot with 400 milliamps but not with 800?
Wait, because of the resistance, because of that 18 ohms?
Of course, you have you have a resistance, you are losing current. Compare with a 0 ohms, when you are not losing, you have 12 volts on the light bulb. You have full current there, you have 800 milliamps.
Obviously.
That's the reason why it's getting hot when you lower the brightness, and actually you lower the current, because the transistor has to lose current. Not has to lose. You increase the internal resistance on the inside of the transistor and you start losing current.
Obviously, current.
How you are limit the current to 400 milliamps? You are increasing the transistor internal resistance.
True.
Just tell me what you don't understand. Just tell me, because it is important for you to understand this.
Now I understand. Now it all makes sense.
So indeed, you increase the current, and you expect, okay, this transistor probably will get hotter.
Yeah.
But not, because you lower the internal resistance. It's like a wire. You know what I mean? It's like a wire carrying 800 milliamps.
Yeah.
You sure understand?
Mm-hmm.
No, just tell me. We can sit here more hours to explain you this. You know, just tell me if you didn't understand.
I understand.
You sure?
Yeah.
Okay.
100%.
It's about the principle to understand. I don't want to calculate. Just to understand what's happening. Why the transistor is getting hot, actually carrying less power. Because it's carrying less power, right?
Yeah.
You have less current. You have less voltage on the light bulb, right?
Yeah.
Yeah.
So you have to increase the current.
To do what?
To not getting hot.
No. So you have 400 milliamps, yeah, right?
Yeah.
Okay, I can come with 24 volts, and I will have 800 milliamps, and the transistor, it will have internal resistor, it will be the 18 ohms. So even if I'm increasing the current to 800 milliamps, this transistor, it will be hot like hell. You understand?
Yeah.
So it's about the internal resistance of the transistor.
Okay.
You understand? Yeah. It's all about that. And the next lesson, it will be directly related with this.
I'll get my prayers.
So you sure understand?
Do not fail. Yes.
You sure you understand that? That's the thing, to understand.
Yeah.
Okay. Okay, let's stop now and see you next time, yeah?
Yeah.